Hi guys. Um, in the previous video, I tried to solve this problem, and then I failed because it takes so long time to after submitting, so time limitation kind of error. So I read the editorial, and then I realized one of the serious problem with my solution with backtracking, because, for example, like let's say that we first visit here, and then visit here, and then visit here. So here we have the count to 3, and then from here we try to visit this way and this way, this way, this way, many other things. So we finally found this one. So, but the thing is that from here, the shortest path is to be here at once instead of going this way, right? So the previous work is actually useless, right? But this useless thing happens all the time. Even though I, find this way, the next time I go this way, and then I go here again, and then I try to do the same thing again. So, it's all useless. So the thing is, before, when we get here, before going further, we need to find what is the count, shortest count to get here, right? To reach here. So if we found that, oh, it's 2, then we can, start from that 2, right? Instead of this long way, which is 3. So this is how we save the time and efficiently, but my previous solution with backtracking does not work that way. That's mainly because backtracking is depth first search, DFS. DFS first try to, go deeper and deeper, but this time it does not work not in that way. So instead of doing that, I'm trying to solve this with BFS. The way we are trying to do is that, for example, from here, we'll see the next level, and then the count to the next, the number of nodes to the next level is 2. So we'll mark 2, 2, 2 in here. That is the shortest one. And then from here, we'll see the 0. So this is 0. So we'll mark 2 here. And from here, we can go here because it's not 1. And then from here to here, we can calculate the count, right? And then if the count is less than this, we can modify this, right? And then here too. So something like that, we can propagate the count to the next level, which if not 1. So the question is if this is always true. So we have something on here, and then we have something on here. So let's say that one is this way and another is this way, right? So here it propagates value to here. Let's say that this is 5 by 5. Well, something like this. This is 10. Okay. And here, propagate this and start to propagate, right? And then somehow the node in here start to propagate. And then since if this is shorter than this, it will change this value. If this is longer than this, it will not change this value. And then somehow the value in here will start to propagate. Well, the thing is, one thing I'm not sure about this is, let's say that this is count 5 and then this is count 10. Yeah, at this point, count 5 propagates further to the 10. And then count to 10 found that found this, and then this is much smaller, so it will not propagate value to here. Yeah. So yeah, that way it seems like it will work. Okay, so so initially, grid 0 and 0. Let's fill that with 1. 1 is some point we cannot visit. Otherwise, other number means number of point. So this is actually not very correct, but by doing this, let's say some case like this. Well, by doing this, this one, cannot go back, right? Because it's 1. So this is, I guess, necessary. So let's since it's BFS, let's make Q here, and then let's push 0, 0 here as a starting point. So while not Q empty, we can do something like that, and then finally what we need to do is to return the last grid. So actually grid is n by n matrix, so let's grid dot size. Yeah. So grid n minus 1, n minus 1. Let's call this, yeah, let's do it like this, not to confuse. So just like any other BFS, will get front. So this will be pair, and then coordinate, and then Q pop. So here what we gonna do is that we'll check the 8 direction. So previously we wrote this, so let's reuse this. Yes. So from here, hi, I'm doing YouTube live streaming. You wanna subscribe? You wanna subscribe my YouTube live streaming? Oh, I'll let you know my live streaming address.
삼촌한테 물어봤어요.
No, not yet. Could you close the door? Thank you. So here we got the next, and then first thing we need to do is that whether we are in the boundary. So this is a boundary check, and then we also need to check whether this is 1 or not. So this is boundary check, and then if this is 1, we'll continue, right? So now this coordinate, so let's say that count means number of node until the coordinate coordinate is grid chord y chord x. This is the count coordinate. This is the count of so far. So since it's not 1, we're gonna check if okay, so let's say that this is int next count next coordinate is this. So if this is not 1, we'll continue. Or if count this is not 0 and count coordinate is smaller, then next this should be +1. +1 is smaller. I hate this. The next coordinate, then let's do this. No, this is. Then we will change it to this value. Okay. So now and we have to push to that, and only in that case Q.push push is meaningful. So next x, next y will push here. So when this is n, and else if we should not forget when this value is 0, and this is I hate this. This is 0. Then we'll push it 2, right? Otherwise, we'll not do anything. this is smaller. We'll change that. Well, this is also true, right? So maybe we can combine these two because its body is same. So so if count or dirty, then we can remove this. So, and then the thing is, so let's say that this is a set, and then there's some weight, there's some, and then these are all set, and there are some elements in here, node in here, and then that is in the queue, and then somehow this queue is added this value and this value, and then these values are also evaluated, and then it's empty somehow, right? So in that case, we can return this. Okay. Did I? Yeah. Q auto count coordinate was the not x. This is front, and the, not front, first. This is second. So and then what is this x? I copied this from the, so this x might be this one. Yeah, right? And then this is the second, right? Okay. Wrong answer. Oh, -1. Oh, so the last one, final val, this, but final val could be 0, right? So if final val 0, then we'll return -1, else final val. What? Or 1? Is that what you want? Oh, 0. So let's do this special case. Oh gosh. Oh, run does not work either. Maybe because I changed this. Oh. Previously. Previously, this was the what happened? It was substituted, right? And then after adding this, this is not always true. We have to check the size. With the size 1 and like this, something like this, and then couldn't if final val 0 or val 1, then -1, and then final val. Oops. But I solved this after reading this editorial. There are another way to solve this, which is not modifying grid is another way to solve this. I just read the title. I didn't read the explanation, detailed explanation. So let's just think about how to not modify this. So like const, in the case the compilation will fail. So const can be achieved. We should not modify, which means that what does that mean? That means there's gotta be some way to remember those values. So maybe we need to copy the grid one more time. Is that the way? Or maybe there's some more simple way, like map. If you use map, the good thing is that map is better in case we have many ones, and then there are very few zeros. Then if it's like a 5 by 5 and then only the diagonal cells are zeros, then we only need to store only those 5. So that's one of the way we can try. And the other optimization we can think of is that some element of which adjacent to cells all of the cells are not 0 need to be maintained by the map, right? So we periodically remove those. Is that true? That might not be true. Because let's say in some case like 0 and some, let's say, some number, and then some number, they can be different number, right? And then some, let's say that this is 0, and then this is 0, this is 0. In the case we may want to remove this, but the thing is, let's say that this is in a queue, and then this is changed to some, and then this actually can change this to the lower some value b, which is smaller than a, and then this may change this to c. C is larger than b but more than a. Well, this could happen, possibly. So okay, so I think this is it. This is the code, and this is the code. Okay. Next session I'll try another problem. Okay, bye.